Okay, guys, so this is the last lesson of our unit 3.5, System of Inequalities. Good job sticking with the videos this far. I know this unit has been kind of tough, but you guys have worked really hard, and I think we're going to do well when it comes time to assess over this. Okay, so solving a system of inequalities. The first thing we have to talk about is a few of the differences between graphing a linear equation and graphing a linear inequality. So we learned before that if you have a less than or a greater than sign, when we were doing these on a number line, we used an open dot. Well, when we're graphing them on the coordinate plane, instead of an open dot, we want to use a dotted line. And if it's less than or equal to, greater than or equal to, we want to use a solid line. So that would be the same thing as using a closed dot if it were just a number line. Now, the other thing that we have to talk about is shading. So not only do we have to change the lines from dotted lines to solid lines, we also have to shade up or down depending on what we have. So if you have a greater than or a greater than and equal to, we shade up. And if you have a less than or a less than or equal to, you shade down. Because we're always talking about y being greater. Well, y gets greater as it goes up on the y-axis. And if it's a less than or equal to, we're talking about y being less than. Well, y decreases or gets smaller as it goes down on the y-axis. So that's why we shade up and we shade down. So let's look at this first inequality that we're going to graph. We start the same way. We always start on the y-axis with a dot. And then we have a couple of things that we want to talk about. The first thing we want to talk about is the slope. And in this case, the slope goes downhill. So usually we would draw the line going down like that to indicate that it's going to go down 2 over 1. But this time it's not equal to. And we know that not equal to means that it's a dotted line. So this one is actually going to go down 2 over 1 using a dotted line. The other thing that we have to look at is, do we shade up or shade down? So this is greater than, so we're going to shade up. Shade it up. Okay, so let's graph this. So it goes from this point, it goes down 2 over 1, down 2 over 1. We could go up 2, backwards 1. We have to fill this in with a dotted line. And it shades up. So from this line, we shade up like that. Okay. I'm going to take this just for a second, and I know you can't do this. So if you want to pause, watch what I'm doing, and then come back to it, rewind it, and then do this on your own, you can. Okay, so for the next equation that I have, I'm going to blow this up just a second. This one is not solved for y right here. So we're going to go ahead and we're going to add x to both sides. So we have y is less than or equal to x plus 1. So let's go through the exact same process that we did before. This is going to be a positive slope. It goes up 1 over 1. It's okay to use the solid line because it's also equal to. So right here it's showing the equal to. And it's less than or equal to, which means we're going to shade down. Okay, so let me shrink this back down a little bit. So it starts at 1, and it goes up 1 over 1, or down 1, backwards 1. and I can use a solid line with this, it's going to shade from this line, it's going to shade down. So I'm starting at the line and I'm just shading down. So that's graphing just one inequality. The purple one was a different inequality. So what I'm going to show you is what happens when we bring those two together. A system of inequalities is where both of those overlap. So if I wanted to shade the solution is the area inside of the dotted or solid lines where they overlap. So the shaded area of both is the solution. The shaded area of both is the solution. So the solution for a system of equations is a coordinate. The solution for a system of inequalities is a shaded area. Okay, so let's look at another problem. I'm going to go ahead and kind of blow this up a little bit. Okay, so I'm going to do the two different colors just like I did before. So this is greater than, so it shades up. Greater than 1, not equal to, so it's a dotted line. We're going to put a dot at -1. There's no x, so this is a horizontal or vertical line. And it's going to shade up because it's greater than. Okay, so this is x. X is at 0. It's also a dotted line, but we know that x has to be a dotted line vertically. Now, this is a weird one. Anytime you have a horizontal or vertical line, y still shades up or down. But this is saying that x is less than 0. So which direction would you shade if x is less than 0? You would shade to the left because that's the direction where x is less than. So we want to put our dotted line in, and it does go right down the axis. And then we want to shade this direction to the left. And we want the area, the shaded area of both. So the solution is the shaded area of both. Okay, so let's look at this next one. The first one's already solved for y, so good. The second one is not, so I want to go ahead and do that. So let's subtract 3x from both sides. So 4y is greater than or equal to -3x plus 12. Divide everything by 4. Y is greater than or equal to -3/4x plus 3. Okay, so this one is going to graph down because it's a negative slope. It's greater than or equal to, so it's going to shade up. So it starts at 3. It goes down 3/4, or up 3 backwards 4, but either way I can't do any more. And it's going to shade up. Okay, so then let's look at this other one. It's going to be a positive slope, but a dotted line because it is not equal to, it's going to shade down. So it starts at 2, it goes up 1, over 1, or down 1, backwards 1, and it's a dotted line. And it's going to shade down. So we're talking about the overlap of the shaded areas where they are both shaded is right in here. All right, let's look at this last one. Neither one of these are solved. So we're going to solve them both. So let's start up here. Let's subtract 2x, subtract 2x. So we have y is greater than negative 2x plus 1. This is a negative slope and a dotted line because it is not equal to. Greater than shades up. Okay, let's solve this next one. We're going to subtract x. Negative y is greater than or equal to negative x minus 2. Divide everything by a negative 1. And when we divide by a negative, the same rule applies to the inequality. We have to flip the inequality sign. So y is less than or equal to negative x over negative 1 is positive x. Negative 2 divided by negative 1 is positive 2. So this has a positive slope with a solid line. It is going to shade down. So since I already have my pink pen out, let's go ahead and graph that one first. It starts at a 2. It goes up 1, over 1, or down 1, backwards 1. It is a solid line, and it's going to shade down. And then I had the blue line starting at 1. It goes down 2, over 1, or up 2, backwards 1. And it's a dotted line. And it's going to shade up. Which makes our intersection the shaded area of both right here. Okay, you have a few problems to do with this. Remember, you just have to do the odds and then make sure that you're doing all of the practice for the review problems.